All right, guys. So let me just recap what have we covered in the security portion, and what are we going to do in the class today. So we had started up with AAA. We did access list. We did the ASA theory, ASA lab, URPF. We covered the data plane attacks and management plane attacks in the last class. Okay, so in the class today, and I guess this would be the last class for the security from the topic so far. Okay, we of course have some more security topics from IPv6, but from IPv4 and the service point of view, I guess we have covered a lot of them. Okay, so in the class today I will discuss two topics. One will deal with securing the management plane. I know we talked about management plane, which was telnet versus SSH, right? Today it's not about what is best, like whether we need to go with telnet or SSH. It's about uh, disabling the other interface. For example, let's say I have a router. Okay, I have one interface where I have enabled telnet. Agree? Now there could be other interfaces, the management interfaces, where someone can try to pass a DOS attack or a DDoS attack. He can try to do a telnet, he can do a try to do a SSH, and what router behaves and how the DDoS attack is caused, and how do we take care of this uh, management plane. There are other management protocol like SNMP. There are a couple of them like telnet, SSH. You have the STTP, STTPS, right? So we will discuss how to secure the management plane with the help of this technology, management place protection. And there is something for control plane as well. Control plane in the sense where we have the access list, the OSPF traffic, the BGP traffic, the HSRP traffic, right? The traffic which, let's say this is my device. Okay, this is my data plane and this is my control plane. So if a traffic comes for an OSPF, so basically data plane will not do anything. It will send to the control plane, and the control plane will check the routing information and accordingly send it. Now there is a possibility if you send lot of traffic, okay, and gradually what happens, your control plane will be choked out. It will be exhausted. There is no more CPU left to process any packet. And what are the behavior? You will see the drop in the packet level. You will see there is a latency increasing, right? So we are gonna put a rate limit in the sense I'm gonna allow only so many traffic at a time. If something comes up, then they have to wait. Instead of getting dropping, instead of the whole device going down, we are gonna put a rate limit. Okay, that's about control plane policy. So today we will see first how do you take care of a device from the management protocol point of view, and the second protocol or the second feature, that is control plane policy, which will deal with the control plane filtering, or the rate of the traffic that we can set a limit to, that so many traffic is only has to be allowed and not more than that. Okay, so let's go to the topic. I'll give a lot of lab this time, because the lab will make you guys engaged. There won't be a tough lab, but yes, you can observe the packet flow and I'll let you know what to do. Yeah, so this was the traffic, which this was the management plane attack, which was about telnet versus SSH. Okay, we know SSH is better. So in the class today, we will talk about securing management plane. So let's say I have a device, a Cisco box, okay, and I have been receiving lot of traffic on multiple interfaces. What kind of traffic? It could be traffic from telnet, SSH, it could be SNMP, it could be STTP, STTPS. Okay, the management traffic that I'm focusing right now. What happens if a management traffic is being sent to a Cisco box? What is Cisco box going to do? It's going to take some of the utilization from its CPU. What kind of utilization? Let's say if a traffic just enters on this interface, the Cisco box is gonna check lot of things, whether you have a local username password defined, should you allow this traffic or should you allow this user. If there is no local username password, then you will try to see if you have a AAA configured, right? So there is certain percentage of CPU getting engaged. If let's say the credentials were wrong, now Cisco box is gonna take some more percentage from the CPU to respond back, right? Say that connection was lost due to credential failed, or let's say when you have SSH configured over here, but someone is trying to do a telnet. What is Cisco box going to do? Cisco box is gonna process the telnet packet, and it's gonna say that connection lost, right? You might have seen that. If you have configured SSH and if someone is trying to do a telnet, Cisco box will take certain percentage from its CPU to respond back to the user that this is not the right connection, right? Connection lost or remote not responding. Now let's take it in from DDoS attack or DOS attack. Okay, it's nothing but it's denial of service. Now what is this? What is DDoS or DOS? Let me say, let's say I have a Cisco box, okay, and there are group of attackers from multiple locations. Let's say there are few from Iraq, okay, who are continuously sending the packets. Now what do you mean by packet? It could be any packet. It could be a ping packet, it could be a telnet packet, it could be a SSH packet. The device is taking certain CPU percent to respond back that you are not a rightful person, or you are not a rightful authority, or you are not a or let's say the telnet is not enabled, right? So it's taking some of the CPU. Now let's say you have few more traffic hitting from China. Let's say there are some group of hackers who are in China, and they are also making use of the telnet traffic to to just just put this device down, because the CPU is getting utilized and the Cisco box is trying to answer each and every request. Similar way, the traffic can be coming from a different location. Now this type of denial of service attack is called as DDoS. Okay, D for distributed. It's a distributed denial of service. You're getting hit from multiple regions on a same box, and the box is trying to respond, which is taking the extra percentage of CPU. So basically the feature or the functionality of this box is degrading. It's not able to do its normal job, right? This is DDoS. What is DOS? DOS is something where the hit is originated from a single location, might be China. Okay, you are one group of people and you're getting a lot of DOS attack, might be like 10 lakhs of attack in just 1 second of time. That's called as DOS attack. DDoS is when it's distributed, okay, and you're just trying to hit the server or a router or a switch. Now we are gonna make some privilege on the box to restrict this kind of DOS or DDoS attack, and that's called as MPP, management uh, prevention attack, okay, or we call it as management place protection. So basically anyone who is trying to hit you on a box will either use telnet or SSH or ping, because they are very simplest option, and all these boxes by default will will be default enabled with those configuration, right? Telnet or SSH or ping, because these are some mandatory things which everyone knows that a box is gonna have it. Now the problem is that the attacker can cause this attack on any interface. Let's say this is a box which is having 8 ports. Okay, where do you configure these things? You configure it over here. You configure like line VTY 0 to 4, and you configure SSH. Now anyone can hit it from any of the interface. They don't have to only be reliable on one of them, right? So that means all the interface are eligible to get those traffic to the line VTY. Agree? Now that's a drawback of a default behavior, and that's why the attacker is causing the impact. Now what I'm gonna do is, let's say I have the Cisco box, I have the multiple interface, I have configured my SSH or telnet, whatever it is. Okay, I'm gonna put implicit deny on all the interface. Okay, I'm gonna put implicit deny on all of them other than one interface. Let's say this is also deny, other than one interface which I know it's for the internal use, so that my internal user can take telnet or SSH, right? You're getting my point, right? I'm gonna make use of some feature so that all the interfaces are put up in deny other than one interface which is really required for me, for my user to connect to the box. How do you put all the interfaces on implicit deny? Is with the help of MPP. Okay, management plane protection. So you're gonna protect all the interfaces. It will now act like your firewall concept. What does a firewall say? By default, all the ports of a firewall are be implicit deny. If you need something, you're gonna mention that, you're gonna put permit statement, and then the packet will be allowed. Otherwise they are deny statement. Similar way, on a Cisco IOS router or a switch, on a management point of view, especially the management traffic, you're gonna put deny on all the interfaces. Okay, except one which is really required for your users to connect to the box. Okay, that's a general meaning of MPP. We can try this. Only the concern is we cannot do it on the GNS lab. Okay, not till the extent. The reason is it's a new feature which works on certain versions only. Okay, so I was trying to do this, but I was not able to do because the GNS images are not compatible with this. But from the production point of view, yes, you should know about this. Okay, but I will show you how the telnet uh, packet are being responded by the devices, which you may not be aware of. Okay, so this is a general explanation of this feature. Basically, you're gonna restrict the interfaces from the network management protocol. You're gonna restrict the protocol that router permits by default. What are the management protocol that we talking about? It's telnet, SSH, SNMP, HTTP, HTTPS. What happens once you enable the management plane protection? It's basically all the interfaces uh, will be restricting this. Okay, until or unless you have something dedicated. Only one of the interface will respond. The rest is gonna put a deny. What else? Restricting packet, management packet. Okay, so basically you're gonna get a control over on the management of the device, more security. What are the other benefits? You're gonna get the support for the network scalability. Okay, and the non-management interface, the package can be improved. Okay, there is no need of applying lot of access list, because applying lot of access list is again internally gonna put a impact on the CPU. Because let's say you had multiple interfaces, right? You would have thought that instead of MPP we can also go with interface access list. That means you have your line VTY telnet or SSH, and you want to block all the telnet SSH with the help of ACLs, right? Now, even if some attacker hits or do a telnet on this interface, now there is one more disadvantage of ACL is it's again gonna spend some certain percentage of CPU to make sure that whether the packet is genuine packet or not. So ACL is not a good point from the DDoS or DOS attack. Okay, so you are gonna get advantage over on ACL with the help of MPP. That's an advantage of using. Management packet flood on switching and routing interface are prevented from reaching CPU. That's true. So when you have your the Cisco box, okay, when let's say you have enabled MPP on this box, now any traffic which is coming other than the dedicated interface, any other interface, the MPP will just stop it. It will just stop it in a silent way. Silent way in the sense it's not gonna take those packet to CPUs. Okay, so CPU is not even gonna know that something is happening on the interfaces. Someone is trying to telnet or something. Okay, so to demonstrate this, what I do is I have this part from my lab over here, and I'll just show you what happens when you do a telnet. Let's take it from a attacker's point of view. Let's say I'm attacking my device. We will see for every telnet, one telnet hit, there will be like 2 to 10 packets that router is originating or the router is generating to respond back to the person. Am I audible? Is the internet connection getting dropped frequently? Hey guys, sorry I got disconnected. So, do you guys see my screen? Okay. Okay, so I am gonna consider these two devices from my lab. Let's take the console of this. Or let me redo this. Let me reload. Let me reload. Let's take the console. So this is my router and this is that switch. Okay, so on the router I'll configure the interface, but let me see if I have it from my previous lab. No, there is nothing. So let's configure it. IP address 192.168.100.255.255.255.0, no shut. Let's go to line VTY. Okay, and purposefully I'm gonna enable SSH. Okay, I'm gonna enable SSH, not telnet, because for the testing purpose I will do telnet to make sure what happens when you don't have telnet and how the device is gonna respond back. Okay, so let's say I configure SSH. Okay, I don't need a username or something, or let's say I need to make it login local. Okay, let's configure username, because then you will ask me why didn't I do that. Fine, the basic the basic configuration. Okay, now I'm on the second switch, which is the switch which says DHCP relay server. Okay, so what I'll do is I configured telnet. So basically I configured SSH here, not telnet. I configured SSH. Okay, and then I'm trying to do a telnet. So why am I doing this? Because I want to see when I do a telnet how the router is gonna respond back. Let's take ourselves as a attacker point of view. Okay, as a attacker, if I do a DOS attack on a Cisco box, let's see what happens. So let's first try to ping to make sure we are reachable and we are all good. Okay, so I have to have some IP with me. Interface GI0/0, IP address 192.168.1.1.255.255.255.0. Okay. Since it's a L3, I should first make no switch port and then I'll ping. It's good. Okay. I'm able to ping. Now let's do a telnet. So when I do telnet, what am I expecting? It should fail. Yes, it's failing. I am okay with that. Okay. Now whatever test I'm doing, that's without enabling the MPP concept. Okay. This is a general behavior which your attacker can do on your boxes, right? And he's not interested to take the login. He just want to cause your device down. Now let's try what the device does when someone is trying to do a telnet. Okay, so I enabled some debugs there. I'm going to redo the telnet, and let's see from this box. You see, for one telnet packet, the device generated couple of packets to respond back, right? How do you think you got this message from? The message was sent by that router, and the router internally communicated to its CPU, and it conveyed the message that you are not supposed to be allowed, or you're or let's say I'm not able to connect to you. So what are the packets that the the victim box generated? Okay, so basically you initiated a packet as telnet 192.168 on this IP. That was your traffic. Okay, which was originated from the attacker point of view. Later on, you see what is your device going to do. Your device is gonna send some return traffic or a responding traffic. Now let's say someone does this in a multiple times. Okay, so let's say someone is doing like lakhs of attack. You can just expect the router responding back just get increases, like in 1 second or might be in 1 minute. You will see the router is now trying to respond back. Now this is not good. Okay, that feature, the default feature of the router is not good. So we need to take care of the management plane. Now let's try to do the same test by enabling the MPP. Okay, so I'll go to the server, I'll go to configuration T. There is something called as control plane host. Okay, it comes under the subset of the control plane policy. Even though we are talking about the management protocol like telnet, ping, SSH, SNMP, but if you see from the command point of view, it will still come under the control plane itself. Okay, so under control plane itself, we are gonna configure restriction to these management traffic. So I say control plane host. Okay, if I do question mark, there should have been some additional comments. Okay, so basically this is not supported in this particular GNS feature. The command should have been something like management interface, whatever interface that I am setting it up as a legitimate management interface. So let's say it was 0/2 and I would have said allow. Now what happens is only this interface is authorized to respond to telnet or SSH. What about the other interfaces? If someone is trying to do a telnet on other interface apart from this, what is going to happen? Do you think the router will still do these many things? Router is not going to do any of the things. Okay, what router will do is router will silently put this message off. Okay, it will not process it. It will silently drop that packet. Okay, it's not gonna do anything to those management traffic like telnet, ping, SSH or SNMP if you send it to any other interface other than this interface. Automatically the feature is enabled. It will see the traffic is a management traffic, it's not coming over on this. So what does it do? It will silently drop the packet. It's not going to CPU at any cost. Okay, the CPU will not be engaged. Now this is something to secure your management plane traffic. Okay, so I cannot show that, but cannot show it over here because of the limitation of the box. Okay, that this feature is enabled on like the latest boxes. So let's see MPP Cisco. So it's on Nexus, etc. We have this feature. This is the MPP. Okay, so you also have for iOS, but not for everyone, every devices. For the latest one, see MPP. So you have this versions. Let me show you the command. If there is a command here. Yeah, so these are the commands that we set. Okay, so we go to the control plane host. As I said, it's a subset of control plane policing. Okay, we go to the management command. I'm gonna put the interface, I'm gonna allow, and which protocol I'm gonna allow, that matters a lot. Okay, there are couple of protocols like you have HTTP, SNMP, SSH, TFTP. There are couple of management traffic protocol, right? So for which traffic do you wanna enable this? So you can set that. And how do you validate if the command is right or not? So with the help of this command. So when you do this show command, you gonna see how many such management traffic were recognized and it just got silently discarded. Okay, so that's gonna be visible. So let me see if, yeah, something like this. This is the command to enable this. Okay, so here we are trying to allow SSH and SNMP over on this interface. So you can see a management interface features enabled on control plane host path. So anything else like telnet, TFTP on any interfaces will be silently discarded. Okay, it's this, the router or the switch is not gonna respond back, or the CPU is not engaged. So you can see the packet processed. So it says 0 because they are allowed. Okay, anything apart from SSH, SNMP, you would have seen some packet. Like if someone is trying to do a telnet, you could have seen the packet processed as 9 or 10. That means those many packets were silently discarded. Okay, so this is one of the feature of the management or the security point of view. Let's go to the next topic. So you have everything. Might be if you have some platform, you can try this. I have given all the debugs and how do you enable the debugs. Okay, so that was without MPP, and with MPP these are the commands. This is how you gonna set your telnet. Okay, and you can give a telnet test. So once you do a telnet test from a device for a testing purpose, you can see the packet were processed. Okay, so on that interface you got some packet for a non enabled protocol, and you just silently are dropping that. Okay, what are the benefit of MPP? It's restricting the router. Okay, it's restricting the router to allow the network management protocol. By default, if you do any network management protocol attacks, your CPU of your router will be used. The router will start responding back. Okay, which will not happen now. It will restrict the management protocol. You don't need to add the access list to achieve this, because access list is once again gonna do the behavior of responding, right? We don't need that. And it silently drop the denial packet. Okay, it's not gonna forward them to the CPU. So this is some versions which we can see MPP. Okay, the next one is securing the control plane. Secure control plane attacks. Why do we need control plane issues, or why do we see control plane issues, or what do you understand by control plane attack? Okay, so let me talk from the Cisco device point of view. Let's say this is a Cisco switch, and similar way I have a router. Okay, we know that in a Cisco switch we have something called as control plane and a data plane. Let's say this is a control plane and this is a data plane. Data plane is just forwarding of the data. But when you receive some traffic which is OSPF or a VRRP or a HSRP based, or a AAA based of traffic, your data plane cannot make the decision, okay, about forwarding. It will send those special traffic to its control plane. Control plane will have all the tables like the routing table, the ARP table, all those things, and it will make its lookup, and it will say that go back or go out over on this interface. That's the work of control plane, and we are talking about securing that control plane. Okay, this was in the case of switch. In the case of router, we have the same data plane. Okay, and over here we have something called as route processor. Okay, the same approach. If there is a traffic which is coming as a special traffic which the data plane cannot handle, it will send to the route processor will check the route lookup, all those things, and then it will send back. Okay, once again we are uh, trying to help the control plane. Okay, so route processor in router and the control plane, or whatever we call in the switch, is something which we are gonna take care. Okay, so basically how can I limit this, or how can I limit this? I can make use of access list. If there is traffic between two users and I want to limit, then I can use a access list to say permit or allow. Right now, the problem with ACL is that it's again a part of control plane, and it's CPU intensive feature. So we don't need ACL. Okay. So what are the some traffic that I'm trying to focus now? We am trying to focus OSPF, BGP, VRRP, HSRP, GLBP, uh, We can also say the sometimes the management traffic like AAA, SSH. Okay. So basically, these are some traffic which I'm focusing right now in the control plane. Okay, and we are talking about CoPP. It's a control plane policing. Control plane policing. Okay, so one thing is allowing or denying, right? The second thing is putting a limit or putting a rate limit or putting kind of the rate or the rate limit on an interface. For example, if I have a router, if I receive lot of packets on OSPF, okay, now there's chances that there are a lot of processing happening and this packet start getting dropped, right? So what I can do is I can put some rate limit. So what happens is if when I put some rate limit, my traffic for this particular protocol will be limited to only that extent. Okay. The other traffic like telnet or BGP or whatever, they will be still working as good as it used to be. Okay, we are gonna put limit only for one protocol, or let's take in this way. I want to put a rate limit for telnet so that my other traffic like SSH, OSPF are not impacted. Okay, that's about the CoPP. It's about limiting or putting a rate limit on those protocols. Okay. Okay, so control plane policing. So on a router or a switch, we usually use access list, and on a firewall, you know how the packet are denied, right? But we can also use policing the rate limit. We can place a strict rule to allow only so many packets for that particular router or a switch. Okay, talking about these protocol, as you know, what is route processor? It basically inspect packet and which is sent to the control plane, and then it's basically gonna respond. It's gonna basically look up the outgoing interface, and if there is lot of packets, too many packets, then it will just start dropping. Okay, what when this happens, what basically you will see the neighbors are flapping, there is timeout. When you try to do a telnet or SSH on those infected device or those devices which are malfunctioning, the telnet and SSH will now not happen because of the intensive CPU resource going across on on those boxes. Okay, what are the way some of the ways we can achieve this is we can make use of RACL, which is receive access list. This is something like a standard or extended access list which we can place on a high end boxes. Okay, like for example Cisco 12,000 series. This is something which you don't see in a lower end, but on a very high boxes you can see this. These are special kind of standard extended ACLs where you can uh, deny the traffic. Okay, but we don't see this feature on a lower end box. So on a lower end box we have two features. One is called as CoPP, which is control plane policing. The second one is the extension of the CoPP. Okay, so what the third one is gonna do is gonna just divide logically the route processor into three things. One is host, transit, and chef exception. Okay, it's the same thing. It's just a extension of the main topic that we are discussing, control plane policing. And how does control plane policing works is uh, there's a feature called as MQC, which we also see in the case of quality services. Okay, MQC, which is called as modular quality of service. So the COPP is nothing but we make use of this feature called as MQC, modular quality of service, to rate limit the traffic. Okay, and how do you rate limit? It's not one day of the job. Okay, the first thing that you deal with is you need to know how many legitimate traffic are sent across on the box on a daily basis, or you can monitor this for a week time or a month time. Because let's say without doing a proper analysis, you just put the rate limit on day one of your configuration. Okay, now the legitimate traffic can get hampered because of that. So the best practice is try to monitor for 1 month or 1 week or 10 days to see how many traffic are really sent across on this router, how many OSPF traffic are sent across this. So you can check this from the show OSPF packet counters. You can see the process, how much the process the OSPF is considering, and according to that you have to set a rate limit. Okay, let's say the rate limit was like on a daily basis, it was 10,000 bits per second. Okay, but you did not take the precautions and you put a rate limit of 8,000. Now the 2,000 of the legitimate packet are gonna get dropped. Okay, which we shouldn't do that. First we have to analyze how many packets or how many packets in real this boxes are daily dealing with, or in a month, for a 10 days of a span you have to do an analysis, and then you put rate limit of 10,000. Because you know something unexpected coming up like 20,000 is something who is trying to cause an attack, right? Someone is trying to generate some OSPF ROG packet, and they just want to put a lot of impact on the CPU. So you can put a rate limit for like 12,000. Let's say you know 10,000 is the capacity, and for some reason, for some day point of view, might be the traffic is hitting to its maximum 12,000. But anything above like 15,000 is not possible or very exceptional cases, and you don't need such um packets or such so many packets causing the impact on the whole box. So gradually you will lose lot of things. The SSH console will be slower, the other packets, the other processes will not happen, right? So that's about the COPP. You're trying to put a rate limit on the packets that you know that these boxes are dealing on a on a daily basis. Okay, you need to first monitor for a week or a 10 days, and then you get the actual picture of the numbers of those packets that daily these boxes are handling. Okay, so it's called as modular quality services, which is used in CPP. Now how does this quality of service work? So yes, we have not covered quality of service, but let me tell you, quality of service deal with class maps. Okay, class maps are like your access list. You have to mention access list. In the case of extended or standard, you define some parameters, right? If this is the source, this is the destination, this is the service number, allow it or deny it or call it on the interface. That's the whole scenario. Even in the QoS, you will define first and then you will call that on the interface. Now how do you define a traffic, right? So how do you define a traffic? Defining access list is quite easy, because you know what is source and what is destination and what is the service port number, right? But QoS is not about service, or it's not about source or destination, it's about services. Okay, so basically these can be differentiated, or I can say they can be classified on couple of ways. One such way is basis on the IP header. Okay, so on IP header, if you just open up your IP header, there is a field called as DSCP. Okay, So DHCP is nothing but it's differentiated services. So depending upon the DHCP service number, we can set some policy that if we get a IP with a header containing this kind of flag or DHCP number, we are gonna do this. So that helps in QoS. Okay. So what kind of DHCP do we see? We can see them in some decimal formats. Okay. These are the corresponding binary values. Okay, and there is something called as IP precedence. Okay, so every IP header will have these field. So so let's say if you see here, this is your IPv4 header. Okay, also your IPv6 header is gonna carry the DHCP. Now that's a main component for your QoS to make the rule or to apply the rule. Basis on this, you're gonna restrict the flow. Okay, so this is DHCP, not DHCP, it's DSCP. Okay, and IP precedence. So what are the two ways I can make use of my QoS class map? It's standard or extended access list and DSCP or IP precedence. Okay, that's what I showed you here. So basis on these numbers, we can make the rate limit policies. Okay, so once again, this is something which we cannot do completely on the GNS because of the iOS. It's not supporting, but yes, the QoS part I can still show you. Okay, and yes, I can give this as assignment. Might be you can try it. There's nothing complicated. It's very similar to your access list. Okay, so if you take from my lab topology point of view, I'm focusing on this because I get HSRP traffic and I get OSPF traffic, and we can limit HSRP, OSPF if we want. We can also put ping, which is ICMP. We can also try with telnet because we have the users. Okay, so we have a lot of devices which we can try to use and try to recreate them. Okay, so the first thing is creating of access list. We need to make use of the extended access list. So basically what I do is if I open up the instance. Okay, so let's say I open up this instance. I go to conft. The first thing that I need to do is I need to create the access list. Okay, let's say IP access list extended. I give some name. Let's say it as ICMP. Okay, now what do you want to do with this? As I told you, don't deny on the day number 1. The day number 1 to day number 10 or day number 20 is all about analyzing how many traffic these services are using on daily basis, and then you will put a restriction. Okay, so on the day number 1, I consider it as all any to any permit. Okay, so I'm gonna put only permit statement and nothing else. So similar way, I can also create other extended list. Let's say OSPF. Okay, I say IP or I can say permit OSPF any to any. Okay, there is no restriction. It's just about seeing the count. Okay, fine. So I have two extended list. Once I have two extended list, now let's create some class map. Okay, because the class map will be later on uh, relying on these access list. So how do I create a class map? Let's say class map, and I need to write the right word that I have used in the case of defining these access list. Okay, so in the case of ICMP, that was the name. And what do you wanna uh, match, or what traffic do you wanna see? Access list is gonna consider any to any, and these class map are gonna match the traffic and give you that number, that on day number 1 you had 10,000 of OSPF packet going over this interface. You need that number, right? So we are gonna say match access group name ICMP. Okay. Similar way, I can also create a class map for OSPF. I'm gonna say match access group name OSPF. Okay, it's all about defining. We haven't called it anywhere. Okay, we have not done anything so far. Now what I'm gonna do is I'm gonna set a policy rate. Okay, and once again the policy rate will be configured in such a way that if I get something above that number, it's still gonna permit it. It's not gonna block it. As I told you, day one is about just calculating the number of hits I'm getting on this interface. Now I go to the policy map. Let's say CoPP. It's a day one. Okay, I can if for better understanding, I can say day one. Okay, and I say what traffic I'm trying to observe. Okay, and what is my policy rate or policing rate. Okay, I'm not gonna deny any. I'm just gonna put a rate limit. Okay, so the count starts from 8,000 bits per second. So I'm gonna say 8,000. What are you trying to do? You're basically going to check the rate, right? So you're gonna say confirm action. You're basically trying to transmit the packet. Okay, you're gonna see how many packets are exceeding from this. But yes, there is no deny. You're just trying to make sure you set some number, and then you're seeing how many packets are actually flowing beyond that number. Okay, so you're gonna say exceed action. Once again, do a question mark and do a transmit. Fine. So this is how you set the number, because you will not come to know on what basis are you calculating. So you said that baseline of 8,000. Are you getting something above? Fine, that's fine. If you're getting less than that, that's also fine, but you're not blocking anything. It's just a day one configuration. The same thing goes with OSPF. You set the rate limit, or just set the number so that you know what is happening. Okay, so as I said, it's a base number. There's no restriction. Okay, there is no drop so far. It's just a day one configuration. And in production, the best thing is don't put this kind of rate limit on day one. First you need to check for few days. Okay, and then now the actual command of restricting. Okay, now let's say you did some analysis for one day, or might be 10 days. You gonna see the show interface status, where these are gonna help you to understand that there were 12,000 of packet or 15,000 of packet, and then you will put this line. Okay, so you will go back to the same policy map, CoPP day 1. Now you will say class ICMP, class ICMP, and then you will place the command police. Okay, what is CIR? Committed information rate. What is the value now? Let's say the value was 10,000. Okay, and now what do you want to do? That you wanna confirm the action. Okay, now you will transmit. So basically you're gonna transmit so many packets. Okay, but what if something is exceeding? What do you wanna do with that? Do you still wanna transmit, or you wanna drop it? Now you will place the drop command. Okay, so this way, when you limit some traffic, and let's say all of a sudden you see abnormal traffic reaching to the control plane, what is the CoPP gonna do? It will gonna make a normal behavior, or it's gonna normalize the traffic. Okay, it's not gonna impact the other traffic. It will just see the traffic is getting dropped for that particular traffic. So let's say when I did ping, it was a ICMP traffic, right? You sent lot of traffic for ICMP. Might be someone is doing a DOS attack, but you have set some limit for that traffic. If you get something else, your control plane policy will try to normalize that without impacting the other traffic like OSPF, HSRP, right? So that's how you do it, because you have done a proper analysis for like 20 days or 1 month, or let's say 2 months, and then you place this. So you cannot be wrong while setting this, right? So you can give some buffer of 1000 to 2 or 3000, so that any day if the traffic is little up, they don't fall into that threshold and get dropped. Okay, so that's about COPP. And how do you make use of uh, COPP policy? You basically first define either standard or extended access list with permit any. With the help of DSCP and IP precedence value, you gonna match them. Okay, you're gonna match it. So you don't need to do this NBAR. Okay, which is so let's see what is NBR. It's a application policies. Okay, it's a application recognition, network based application recognition. Okay, so some router use this for data flow, inspecting some packet. So don't use NBAR except to match our packet. Basically, it's telling that don't make use of this feature. Instead, go with the uh, the modular way that we discussed. Okay, it's best that you don't drop the legitimate traffic. So first do a good analysis for couple of days and then apply the main thing. Okay, and what is the COPP benefit? It's gonna put the rate limit, okay, to and from the route processor on the control plane. So that ends your topic for the day. It was about the securing of the control plane, but yes, there was one something called as management plane protection, which was a subset of control plane itself, and the second one was this control plane policy. Okay, so in the next class we will take some other topic, might be from NCore or NRC. So let me know if you guys have any doubt, and we will take it to the next class then. So all good with the topic. Any doubt with respect to the topic we discussed today? Anyone using this feature on the production, the COPP or MPP? Okay. Yeah, these features are one thing on high boxes that we use. Okay, on a data center boxes, and second thing is uh, the COPP I have seen, but MPP I have not actually seen. But as I told you, it's something which is used on a higher end boxes. Okay, not something we use. And yes, depends on which kind of organization it is. If organization is dealing with let's say the intradays, or you might be knowing the stock markets, right? So those organization need a quick and very reliable traffic. Okay, they cannot rely on any kind of fluctuation, because the stakeholders or the customers, they who deals with transaction, one small delay can uh, bring the transaction down, right? So in that case, we need to limit all the traffic. We need to give a more importance to the traffic that the organization is focusing on. Other than such type of organization, the others are all good. One or two drops doesn't make any big deal. But yes, from organization point of view, it's sometimes the focus will be to keep on HTTPS. Let's say the focus is on HTTPS. Now they are gonna make all privilege to have a good QoS setup on all the devices. So the privilege is given on the HTTPS, because you never know on in a organization, someone is trying to use YouTube or a Facebook or a lot of other services which can bring that particular traffic down, right? So it's about bringing the quality by suppressing the other traffic, the management traffic or other traffic don't impact something else. All right, guys. So we will meet up in the next class. Have a nice day. See you soon. Okay. I'll pass on the recording and the lab. So during weekend, you can practice this. Okay. See you, everyone. Take care.